Welcome back, everybody. In this lesson, we're going to take a look to see if given points fall on a provided line. So let's get started. As a quick review, here's the general flow of the way things have worked so far. We can take a given equation, plug in numbers, evaluate, fill the answers into t-charts. Let the t-charts give us a point, plot the points to create a line. So we're going to use this process to help us out today. So far, we've used x values, otherwise known as the domain, to find y values, known as the range. Sometimes, however, we need to go backwards. We have to use the y values to find the x values. Regardless of which variable we're given, x or y, the process is the same. We still plug in the x value and solve for the unknown. So let's take a look at this example. Complete the table, then graph. We're given the equation negative x minus 4y equals 24, and a t-chart with given values of x and given values of y. For all 5 of these problems, we're going to just plug in and substitute the given variable and solve for the unknown. So a couple solving type problems, and we will plot the points. Let's take a look at the first one. I'm looking at negative x, which for the first one is negative 8, minus 4y equals 24. Time to evaluate. Opposite of a negative is positive, so you get 8 minus 4y is 24. Positive 8, so we subtract 8 from both sides. Negative 4y is equal to 16. Now we undo multiplication by dividing by negative 4 both sides. Y equals negative 4. First problem is solved. Let's go ahead and plug that into our t-chart. Negative 4, and look at that. We even have a point from the origin back 8 down 4. Now let's go on to the next problem. This time, instead of plugging in an x value like we've normally done, let's plug a y value in. So negative x, I don't know that one in this case, minus 4 times the y value right now is negative 5 is equal to 24. Let's evaluate. Opposite of a negative is positive. 4 times 5 is 20. Negative x is still there, and I'm equal to 24. Subtract your 20 from both sides. Negative x is equal to 4. Divide both sides by negative 1. X is equal to negative 4. So we will plug that one in. Get negative 4 comma negative 5, and there's our point from the origin back 4 down 5. And you would continue with the next 3 points in the solving process the same way. You plug in negative 6 and solve, and so on. So cutting through. If you want to work those, you can pause the video and look at them. You get 0, negative 6. If you plug in 4, you'll find your y value to be negative 7. If you plug in 8, you'll find your y value to be negative 8. Now that we have all of our points, you can draw your line. So whether or not you're plugging in an x or a y, your process is the same. Plug it in, solve, record it in your table, and go. So sometimes you may be trying to figure out if a point is on a given line. In order to do this, all you got to have to do is plug x and y values into the equation. If the x and y values satisfy the equation, they make the equation true, then the point is on the line. If the x and y values do not make the equation true, so they're not equal when you're done, then the point is not on the line. Let's take a look. So 2 examples here, asking the same question. Is this point 2 comma 7 on the provided line? Let's try this. You're going to substitute x and y values into the equation. So instead of x, I plug in 2, and instead of y, I plug in 7. Evaluate. Negative 3 times 2 is 6. 2 times 7 is 14. Combine like terms on the left. I'm looking that 8 is not the same as 10. So these 2 points don't work. Since the equation is not true with the point 2 comma 7 plugged in, that equation is not going to be on the line. Let's try this other one. Same equation, different point. May or may not be there, I don't know. I'm going to plug in 2 comma 8. Substitute x and y values into the equation. There they are. I plug in 2 and 8. Evaluate. Negative 6 plus, what's that, 16. Combine like terms. 10 equals 10. Oh, our numbers seem to work on the right, on the left. Since the equation is true with the point 2 comma 8 plugged in, that point is going to be on the line. So 2, 8 works. 2, 7 does not. Let's take a look at the graph and see what it looks like. Same exact question. Same line, same points. So we'll start by plotting the first point, 2 comma 7. Over here we'll plot our 2 comma 8. You see they're at different positions. Let's take a look at what the line looks like. Look at that. The line missed the point. This point is clearly not going to be on there. The point does not make the equation true, so it's not on the line. The next one, let's draw the line. The point makes the equation true, as we saw on the last slide, so it's going to be on the line. So once again, all you have to do to determine if a point is on a line or not is take the given coordinates, plug them into the equation, and solve. If things match, then the point works. If things don't match, then the point doesn't.